Hello, hello and welcome to this video. In this video, we will continue looking at RC RefCell of Rust. So this will be a quick short video compared to my previous video. So RC RefCell has two issues. One of them we saw in the previous video and we talked about the second, but I don't think we saw an example. So the problem of multiple mutable borrow can be solved with the discipline. Then there is architectural stuff. For example, if you are using multiple threads, particularly with mutexes, then you need to be very, very careful about mutable borrows because you don't know when which thread will run. So that is one thing. The second thing is that if you choose your architecture to something like thread per core architecture, then the problem is somewhat less compared to a multi-threaded with mutex. If your threads communicate via channels and do not take locks, then the problem is far less severe compared to normal multi-threaded program. The second problem which we are going to talk about is that is memory leak. Okay, so let's see an example. We have a struct node which contains value i32. We don't care about this value much. We have a next pointer which contains option RC RefCell of node. Okay, so basically the next can be some RC RefCell node or it can be none. So essentially it looks like a linked list. Okay, now we have node 1 and we create next to none. So next of node 1 is none. And then we create node 2, next is again none. Now what we do is we take a mutable borrow on node 1 and makes the reference of node 2 as the next element. And then we take the next of node 2 and we point it to node 1. So essentially we are trying to establish something like two graph nodes pointing to each other or a W linked list pointing to each other. Now, if you see, strong count of both will be 1. Now, what happens is, no matter what we do, this strong count will remain 1 when this goes out of scope. So, this will be a memory leak scenario. Here, the process is ending, so memory leak won't happen. But suppose if it would have in a function and both node 1 and node 2 goes out of scope, then Rust cannot garbage collect because there is still a reference. So both the references will point to each other and strong count will remain 1. It will never become 0. And then it won't be garbage collected or I won't clean it up. So the solution is that you use weak pointer. So like RC, there is something called weak. Okay. Now there is, let's see the example and it will be clear. We have again parent as option weak RefCell node. And children are RC RefCell node. So look, this is a weak pointer. This is RC. This is an RC pointer. Okay. So when we create parent, we have value, parent, and children. Children are a vector. Then when we create a child, and here we have parent none and value 2, and children are further more vectors. Then let parents own the child strongly. So in the children vector of parent, we push this child. Okay, but child should point to parent in a weak manner. Okay, that is what this weak does. So when you take a reference of parent, then it will be a weak reference. This is a weak count. So if you look at parent's strong count, it will be 1 and weak count will be also 1. Okay, and if you look at strong count and weak count, so you will see that the counts are similar. So here strong will be 1 and weak will be 0. And here child strong will be RC strong count child. So for the parent, it will be strong will be 1, weak will be 0. For the child, it will be strong will be 0 and weak will be 1. Now, here, what happens is if you have a weak pointer, then you cannot use it. You need to upgrade it. The weak is downgrading it. When you downgrade the RC, it becomes a weak pointer. But to upgrade it, you have to, for example, if you look mouse over it, look, it is returning weak. Okay, so when you try to use the weak pointer, it won't work. So what you have to do is you have to borrow parent and then you upgrade it. Okay, and after upgrading, you can use its value, and then parent will be dropped. Okay, here this parent RC will be dropped. So that's all about the weak pointer. You can look at the standard documentation. Let's try to run this. Okay, let's see what is the output. So if you want to run it, you can run it, and we have parent strong 1, weak 1, child strong 2, weak 0. The child strong is 2. Okay, I have counted strong. So ampersand child, the child will have how many pointers? Child count will be 1 because of this when you create this. Okay, and the second would be for what? RC strong count child. I'm not sure about this. Parent 1 strong 1 weak understood, but child, okay, so okay, I got it. So one count will be here and another count will be here. So 2, okay, child strong will be 2. So parent value, if you see here, is 1. As you can see, we have set the parent value to be 1. Okay. So with this, I think we can end this video, because I intend it to be a short one. We will deal with the small slices of technical information so that we understand that what is going on. Now again, the question comes is, should we use RC RefCell or not? So my commentary would be that it depends on your application's nature. If you are working on mission critical stuff, then you should not use RC RefCell. But in general, you can use RC RefCell. The memory leak prevention is possible, and if you are disciplined, then you can manage. In single-threaded program, it is quite usable. The problem really comes when it is multi-threaded. So in multi-threaded, I would rather avoid RC RefCell. Instead, I would use something like QCell or GhostCell or TCell, which we talked about in the previous video. In multi-thread programming, you have to be quite concerned about the safety of the program. So RC RefCell is not a very good idea. It will take a lot of effort to really solve the problem. And if there is a solution like QCell, then there is no point using RC RefCell. So with this, I will end this video. I hope that you are enjoying this discussion on Rust and finding the videos useful for your programming purposes. So I thank you for watching the video, and we will meet again on the 4th day with another video on Rust. So I will take my leave here, and you take care and have a nice day.